So now let's talk about the same interval in set builder notation in terms of and inequalities and or inequalities, those compound inequalities. And I'm also going to give you a small little way to help you remember the difference between those two things. So here I have myself an and inequality. Remember, and inequalities, they always have only the less than or equal to signs, and never greater than or equal to signs. Always goes from small to big. Since it always goes from small to big, that means interval notation is going to be very simple on it. Very, very easy. Okay. So for set builder notation, look how I wrote that. Look, I put a vertical line, instead of the B, a vertical line, which is the such that, and then half of a curly bracket. It kind of looks like a B. Not exactly, but kind of set builder notation. Okay, so to put set builder notation, you put curly brackets around it, and then that such than thing, which is either a comma or that vertical line. Piece of cake. Interval notation, look at the way I wrote it. Instead of writing an I put two square brackets. Whenever you put them together, it looks like an I. Kind of interval notation, right? So I go small number to big number. Smallest number here is -1/3. It gets parentheses because it's not equal to. And the biggest number here is 4. It gets bracket because it is equal to. There you go. Piece of cake. So let's do one problem that applies that. Okay, so solve this inequality here and then graph it and then write it in all the forms. Set builder and interval notation. So let's solve that thing. That bell means that school's officially over. Anyway, so whenever you have 3 parts, like you got a middle part, you want to try to get the variable in the middle all by itself. So we've got to get rid of everything else first. So that 5 first, we're going to subtract 5 there, we've got to subtract the 5 here, and subtract the 5 from the 10. So all 3 little pieces. So over on the left-hand side, I have -15 is less than 3x. The 5 in the middle is gone, is less than or equal to 3. Okay, and now I'm going to divide everything by, just divide the whole thing by 3 and see what happens. -15 divided by 3 is -5. It's less than x is less than or equal to 1 when I divide it. So instead of just writing it like that, well, hey, let's go ahead and graph it. Yeah, let's graph it. Number line, I got a 0, I got a small little number 5, a -5, and the 1. So it gets open circle on the -5, that gets closed, and that's colored in. That's easy. That doesn't look colored in, but it is. There we go. And hey, what are you doing? And then finally, let's write it in set builder. So set builder notation. Remember, set builder has the little curly brackets on it. So I just write exactly what I wrote in the box over there. I just put curly brackets around it. X such that, and then -5 is less than x, which is less than or equal to 1. Look at how many little curlies things that has. Interval. Interval has parentheses and brackets, small to big. Small to big. Smallest number here is -5, comma. Biggest number there is 1. -5 gets parentheses because it's open circle. And the 1 gets a square bracket because it's equal to. It's colored in. There are my 2 notations. All right. How about those notations with or inequalities? Or inequalities, remember these things, whenever you graph them, they're rays going in opposite directions. And I have 2 separate little statements, this one or that one. So set builder notation on the left-hand side. Again, my little reminder, set builder, curly brackets. So you just write it exactly like you see it here, but you put curly brackets around it exactly the same way, right? It's exactly, oh, but it has, what is this thing? It has something that looks like a U in it. That is another piece of notation, and it just means the union of those 2 sets. Union, as in these 2 things put together. Okay, so anytime you have an or inequality, you always use the U to separate them in either one of these notations. Okay, and then for the interval notation, again, it might be easier if you just look at a number line and then pick out all the intervals from it. So I've got a 0, I've got a negative 1/3, and I've got a positive 4 on here. I know this is colored in to the right of 4. It is open and to the left of 1/3, negative 1/3. And just go from left to right, smallest to biggest. So here's one interval. Smallest is negative infinity all the way up to negative 1/3. It gets parentheses because it's open. U for union. And then I go to the 4, left to right. It gets a bracket because it's equal to all the way to positive infinity. Never a bracket. See? Very, very simple. Let's apply that to finish this off. Whoa, whoa. There we go. Is that in there twice? I don't know. So solve that set of inequalities, graph it, write it, etc., etc. There we go. So you have to solve OR inequalities separately. 2x minus 1 is less than or equal to negative 7, or 4x plus 3 greater than or equal to 7. You solve them separately. So on the left-hand side, let's add the 1 over, so 2x less than or equal to negative 6. Divide by 3. X is less than or equal to negative 3. Okay. Over on the right one, 4x, let's subtract the 3 over, is greater than or equal to 4. Divide by 4, x is greater than or equal to 1. So whenever you go to graph it, it's an OR inequality, so we're going to have two rays. So the negative 3, I need a negative 3 on here, and I need a 1 on there. Okay, the negative 3 is colored in to the left. The 1 colored in to the right. Set builder notation. I put curly brackets, x, such that, then I just list out my two intervals. X is less than or equal to negative 3, union, x is greater than or equal to 1. Close the brackets. Interval notation looks like this. Smallest to biggest, taking each one of those intervals. So from left to right, smallest is negative infinity, always gets parentheses, comma, all the way up to negative 3. This one gets a bracket because it's equal, union, another bracket for the number 1, and then all the way up to infinity. There you go. And that's it. Very, very simple, right? Not too bad. Hopefully that clears up a little notation stuff for you. And why don't you go ahead and just practice it just a little bit more here. You've got a couple of problems. There are going to be some strange things that happen, so I do want you to actually work through those problems. Some strange things are going to happen, and then we'll talk about them when you're done. So pause. Okay, so let's see what crazy business might have gone down. 1 and 2, there weren't any crazy things. It was just straightforward stuff, just doing what we've been doing. So here you go, answers revealed. Number 1, it's a and inequality, so that means like when I solve it, it's going to be a segment, sure. Get the x in the middle, everything else off to the sides, and I get negative 4 is less than x is less than 6, graph that thing. And then put it in curly brackets for the interval notation. Smallest number is negative 4, biggest number is 6. Put those both in parentheses because they're both open circles. Okay. Over here on number 2, it's an OR inequality, so you just have to treat each of those inequalities separately and solve them. Add the 1 over, divide by 3. I get x is less than 0 for the first one. Or, and then, where is it? Okay, on the second one, subtract the 5 over, divide by 2, and I get 3 on that one, and its x is greater than or equal to 3. Okay, so I got two different parts pointing in opposite directions. Set builder notation, separate it with a union, a u. And then the interval notation, again from the graph, it's very easy, just go left to right, negative infinity to 0. It's parenthesis, union, bracket 3, comma, infinity. Okay. On number 3, here's the first crazy thing that happened. Like your x's, they cancel out. It depends on how you solved your equation. You might have gotten something a little bit different than what I have, and that's okay, as long as what you ended up with was a true statement. Like I got 1 is less than or equal to 2. No matter what, that will always be true. What that means is it doesn't matter what you stick in for x, the number 1 will always be less than or equal to 2. So that means your answer is all real numbers. So that's what you'd write. You could just write the blackboard R. You could write from negative infinity to positive infinity, something like that. And then when I graph it, it's the whole entire number line colored in. Okay. On number 4, another crazy thing happened. The x's do cancel out again, but this time you don't get a true statement. You might have gotten something different from me number-wise, but you should also get what is called a contradiction. Like this doesn't make sense. 10 is less than negative 15. It's not. 10's bigger. That's a contradiction, which means that there's nothing that you can stick in for x to make that thing true, which means you have no solution. When I graph it, it's a number line with nothing colored in. I got nothing on there. Whenever I go to write the answer, I have my set builder notation, my 2 curly brackets, but I keep it empty. It's called the empty set. Let me write that. Empty set. And that's what that symbol, the O with a slash mark through it, that's what that also means. So just to recap there, here's the possibilities that you can have for solutions. The first one is you have an infinite set of values. And in other words, whenever you go to solve your inequality, there's no funny business, and you just get yourself an inequality at the end, like x is greater than 4. And you just write it in whatever form you're feeling like at the time. And then number 2, yeah, just a second. I've got a call.
Hey, what's up? Yeah, I am. Sure, yeah, I'll take it. Okay, cool. Bye-bye.
Okay, anyway, so the second one is if you have no solution and you're going to write either the empty brackets or the O with a slash mark through it. And this happens if when you solve an inequality, you get a contradiction. Something that's dumb, something like 4, if 3 is greater than 4. Yeah, there you go. 3 is greater than 4. Then you get no solution. The last one is if you have all real solutions, all real numbers. You either write the blackboard R or in set builder notation instead of all x such that x is less, or negative infinity is less than x is less than infinity, or you can write it in interval notation, negative infinity, comma, positive infinity. And this happens if you get yourself an identity, a true statement, something like 3 is less than 4. There you go.
So, this is, you come up as Ravel on the phone?
I still haven't changed it.
Yeah. So everybody, this is Miss Matamoros.
Hello.
And maybe you had her as a teacher once upon a time. Yeah. So yeah, this will be good. Thanks. I'll come by and visit sometime.
Okay, sounds good.
Okay. All right.
So that concludes our lesson on linear inequalities. We were talking about how to solve and graph some linear and compound inequalities, and then also how to write their answers in either interval or set builder notation. And the picture there's one other kind of non-mathematical picture that represents inequalities in some kind of way with colored pencils. And there's Rowan again giving you your assignment. Now if you're on the complete flip model, you remember that you are doing your assignment in class. If you are one of those that has to do your assignment at home, then make sure that you're doing both kinds of notation, set builder and interval notation, and don't forget about your challenge problems. There you go. See you in class.